Okay, Greenlight, explain it. Explain it to me like I'm me. Like, what is it? How does it work? How will I use it?
Yeah, so if you're using anything like Wallet of Satoshi or Spark or any of the web-based front ends, you very much already have an experience that is similar to Greenlight. What you usually have is some server running your node and a client that talks to it, right? That can be your front end, that can be your accounting software, that can be some security system that makes audit logs and stuff like that. So we have these two components: a server running on your server usually, or Wallet of Satoshi in case it's a custodial system, and the client which presents you with a front end, scans your QR codes and stuff like that. Now, the idea of Greenlight is what happens if if every single user gets their Core Lightning node. We run stock Core Lightning on our servers, and we rip out the part that is actually handling keys. And so we still have the system where we have a client on your phone, on your laptop, wherever on your iPhone smartwatch or whatever, talking to a server. This server now, instead of running on your infrastructure or Wallet of Satoshi's infrastructure, runs on Blockstream servers. The node doesn't have the keys anymore, so we need to have some place where we store the keys, and we simply do the same that we did for the client connection, and we move it back to the user. So the user has the client and has a signer, and the node is just a dumb operational process that manages state and doesn't do much else. And so what you end up doing is you now can, as an app developer, you essentially take our API, that is our programming interface, allowing you to get access to our servers, and in a matter of seconds, you can essentially say, "Hey, spin up a new node for a new user." The keys for that user reside on the app itself, right, on the user's device. And the node is spun up in our cloud. And once that is spun up, the client essentially connects to it and can start performing operations on it, sending, receiving payments, opening channels, you name it. Whenever something is touching the funds, as in, hey, I'm receiving funds, or I'm opening a channel, or I'm sending funds, or closing channels, we'll need a signature from the keys that are associated with those funds, right? Those keys reside on the user device. And so what the node does is essentially it sends that signature request to the device. Now, that all sounds very, very fancy or not, depending on how you look at it. The real trick is, how can we make sure that an attacker or a Blockstream operator having access to the server, to the node itself, can't do anything with the funds, right? If I were accessing the node and I were to say, "Hey, send all funds to Christian's address," and the signer sees that, they will probably just sign it off, right? And so we had to take the signer and add additional verification on top of it. And the way we do it is essentially every single client you register with your node has an identity. And the signer will verify that, oh yes, this payment instruction that I'm now being asked to sign off actually came from an authenticated user that I trust, and not some attacker having access to the node on the server. And so this end-to-end verification is the core innovation here. And we actually just merged an update yesterday on it, so it's very much still in flux, but we're getting there. And so the overall flow is very much like you download an app, you open the app, get to write down maybe a seed, maybe not, depending on the decisions of whoever developed the app and whether they trust seeds or not. Mm-hmm. After the seed is being stored, Blockstream servers are getting asked to spin up a node. The client connects to that node. You can now interact with the node. As soon as you touch funds, You send instructions to the node, which are then forwarded to the signer. The signer will use those instructions to verify, hey, yes, this is actually Peter asking me to send a payment, and only then sends back the signatures required to perform these actions.
So you haven't just built it for you guys to build into your own wallet. You've built this for everyone.
So I built it very much for my own needs,
Okay.
but it is obviously something that is very powerful. So I mentioned before that end users are sort of our target audience here, right? Because end users are the ones that need the assistance.
It's me.
You would be a perfect customer for us. The problem is I really do suck at front-end design. User experience, user interfaces, I can't do it.
I can help with that.
Maybe we should collaborate then. The core point is that end users are but part of our target audience, right? Who else is suffering from these issues? App developers. App developers are having a really hard time to develop apps that are integrated with Lightning because they usually have to bundle the Lightning node with their application itself. And that requires them to learn all of the intricacies of Lightning, but also how to code best practices into the node. Because once your app is on the phone of a user, you're not getting to touch it anymore. That would be you commandeering their funds, right? And so channel management and all of that stuff either has to be exposed to end users or you have to automate it. And trust me, automating is really, really hard because we don't even know what best practices are. And so what we the target audience that we are talking to more directly is app developers.
Okay.
Because they can now use our programming interface to spin up nodes on our infrastructure, integrate with just using RPC calls, and not care about any of the rest.